Welcome to MRL. In this learning session, we'll be learning about quadrilaterals. Now, what is a quadrilateral? A quadrilateral is a polygon of four sides. A quadrilateral is a coplanar closed geometrical figure bounded by four line segments. A quadrilateral is a coplanar closed geometrical figure formed when four non-collinear points are joined in pairs by line segments which meet at their end points. So this figure is a quadrilateral. Now, how to name a quadrilateral? A quadrilateral is named by taking the vertices in a particular order. Each vertex is denoted by a capital alphabet. Now we have the four vertices here of a quadrilateral. We name the quadrilateral as A, B, C, D. We take the vertices in a particular order, and that is how we name a quadrilateral. Now the conditions for a quadrilateral, for any figure to be a simple quadrilateral. In a quadrilateral, all the sides must be line segments. The sides should not cross, and the figure has only one interior. If you look at this figure, it has got only one interior, the sides are not crossing, and also the figure has what you call only line segments. Now this is not a quadrilateral, nor this is a quadrilateral. Here the sides are crossing, and here one of the side is a curve, and therefore it is not a quadrilateral. Remember that. Now the parts of a quadrilateral. A quadrilateral has four vertices, A, B, C, D. It has got four sides, A, B, B, C, C, D, D, A. It has four angles, angle A, angle B, angle C, angle D, and it has two diagonals, AC and BD. In all, a quadrilateral has 14 parts. 4 plus 4 plus 4 plus 2 is 14 parts. Remember that. A quadrilateral has 10 elements. That means leaving the vertices, 4 plus 4 plus 2 is 10. So it has got 4 sides, 4 angles and 2 diagonals. They are the elements of a quadrilateral. The elements are required to construct a quadrilateral, and to construct a quadrilateral a minimum of 5 elements are required. Remember that. Now to understand the vertices, sides, angles and diagonals of a quadrilateral, let us discuss about the vertices first. A quadrilateral has 4 vertices. A quadrilateral has 4 vertices, and in that AB, the vertices A and B are adjacent vertices, BC are adjacent, CD are adjacent, and DA are adjacent vertices. In all, there are 4 pairs of adjacent vertices, and also A and C are non-adjacent and B and D are non-adjacent. Therefore there are 2 pairs of non-adjacent vertices or 2 pairs of opposite vertices. Remember that. Now if you talk about the sides of a quadrilateral has 4 pairs of adjacent sides. For example, here AB and BC are adjacent, BC and CD are adjacent, CD and D are adjacent. So these are the 4 pairs of adjacent sides. Remember that. And also in a quadrilateral there are 2 pairs of opposite sides. AB and DC are opposite, BC and DA are opposite. There are 2 pairs of opposite sides. Again, about the angles in a quadrilateral, a quadrilateral has 4 interior angles, and in that angle A, angle B are adjacent, B and C are adjacent, angle C and angle D are adjacent, and D and A are adjacent. So we have 4 pairs of adjacent angles, and also there are 2 pairs of opposite angles. A and C are opposite angles, B and D are opposite angles. Now talking about the diagonals of a quadrilateral, we already know what is a diagonal. A diagonal is a line segment joining non-adjacent vertices of a polygon. Now in a quadrilateral has only 4 sides, and it has got 2 pairs of opposite vertices, and therefore only 2 diagonals are possible in a quadrilateral. So we have A and C are opposite vertices, B and D are opposite vertices or non-adjacent vertices. If we join AC and BD, we get 2 diagonals. So therefore AC and BD are the 2 diagonals in a quadrilateral. Please remember that. Now angle sum property of a quadrilateral. We know that a quadrilateral has 4 interior angles, angle A, angle B, angle C and angle D, and the sum of these 4 angles, that is angle A plus angle B plus angle C plus angle D, or angle 1 plus angle 2 plus angle 3 plus angle 4, is 360 degrees. Now to understand this, let us do one thing. Let us join AC. Let us draw the diagonal AC. That means that divides the quadrilateral ABCD into two triangles. Now the sum of the angles of a triangle, that is triangle ACD, is 180, triangle ABC is 180, therefore 180 plus 180 becomes 360 degrees, and that is the reason why the sum of the four angles of a quadrilateral is 360 degrees. Please remember that. Now the sum of the interior angles of a polygon, we have the formula, that is n minus 2 into 180. Here n is 4, that means there are 4 sides, therefore 4 minus 2 into 180 is 2 into 180, therefore the sum of the interior angles of a quadrilateral is 360 degrees. Remember that. We also know that the sum of the exterior angles of any polygon is 360 degrees. A quadrilateral is a polygon, and therefore the sum of the exterior angles of a quadrilateral is 360 degrees. That is angle 5 plus angle 6 plus angle 7 plus angle 8, which are the four exterior angles of a quadrilateral. The sum is 360 degrees. Remember that. The next point of our discussion is what are concave and convex quadrilaterals. Now we already know what is a concave polygon and convex polygon. Let us understand here. A quadrilateral in which none of the interior angles is a reflex angle is called a convex quadrilateral. Also, in a convex quadrilateral, the diagonals are interior to the quadrilateral. If you see here, angle A, angle B, angle C, angle D, which are the interior angles here, none of them are reflex angles, and the diagonals, two diagonals of the quadrilateral are interior to the quadrilateral, and therefore it is a convex quadrilateral. Whereas in a concave quadrilateral, a quadrilateral in which one of the interior angles is a reflex angle is a concave quadrilateral, and also in a concave quadrilateral the diagonal is exterior to the quadrilateral. If you look at the quadrilateral here, ABCD is the quadrilateral, angle C is a reflex angle, and one of the diagonals BD is outside the quadrilateral or exterior to the quadrilateral. Therefore this quadrilateral is a concave quadrilateral. Please remember that. Now the next point of our discussion is regular and irregular quadrilaterals. Now what is a regular quadrilateral? A quadrilateral in which sides and the angles are equal is a regular quadrilateral. For example, here ABCD is a quadrilateral because there are four sides here, and the angles ABCD are equal, that is equal to 90 degrees, and the sides are also equal. Therefore it is an equiangular and equilateral quadrilateral, and that is a square. Therefore a square is a regular quadrilateral. Remember that. Now irregular quadrilateral, a quadrilateral in which the sides and angles are unequal is an irregular quadrilateral. Now if you take a rectangle here, the four angles are 90 degrees, but in a rectangle the opposite sides are equal. That means all the sides are not equal, therefore it is an irregular quadrilateral. So also the rhombus, in rhombus all sides are equal but the opposite angles are equal. That means all the angles are not equal, therefore it is an irregular quadrilateral. And also if you look at this quadrilateral ABCD, here none of the sides are equal or angles are equal still, and therefore it is an irregular quadrilateral. Remember that. The quadrilaterals are classified on the basis of pairs of parallel sides. If the quadrilateral has one pair of parallel sides, then it is called as a trapezium, and there are different types of trapeziums. They are the isosceles trapezium and the non-isosceles trapezium. And if the quadrilateral has two pairs of parallel sides, then it is classified as a parallelogram or a kite. Again we have got special parallelograms known as rectangle, rhombus and a square. So we will be learning all the properties of all the different types of quadrilaterals one by one. So now let us begin with a parallelogram. Now a parallelogram is a quadrilateral in which the opposite sides are parallel. In this figure, ABCD is a quadrilateral, AB is parallel to DC and BC is parallel to AD, and therefore it is a quadrilateral but a parallelogram. In a parallelogram ABCD, AB is parallel to DC and AD is parallel to BC. So remember that a parallelogram is a quadrilateral in which the opposite sides are parallel. Now the properties of a parallelogram, we will be studying the properties of a parallelogram in terms of sides, angles and diagonals. Now in terms of sides, the opposite sides of a parallelogram are parallel. The opposite sides are parallel. That is AB is parallel to DC and AD is parallel to BC. And in the parallelogram, the opposite sides are equal. That is AB is equal to DC and AD is equal to BC. That is in terms of sides. In terms of angles, the opposite angles are equal in a parallelogram. Angle A is equal to angle C, angle B is equal to angle D. Now in a parallelogram, the adjacent angles are supplementary. That means angle A plus angle B is 180, angle B plus angle C is 180, angle C plus angle D is 180, angle D plus angle A is also 180. Remember that. In terms of diagonals, in the parallelogram there are two diagonals, AC and BD. The diagonals are unequal, that means AC is not equal to BD. Please remember, in the parallelogram the diagonals are unequal and the diagonals bisect each other. That means O is the midpoint of both the diagonals, or OA is equal to OC and OB is equal to OD, and the diagonals form pairs of congruent triangles. If you observe here, we have triangle AOB congruent to triangle COD and triangle AOD congruent to triangle COB, and so on. There are different pairs of congruent triangles formed by the two diagonals of a parallelogram. Remember that. Now rectangle. A rectangle is a special parallelogram. A parallelogram in which one of the angle is 90 degrees is a rectangle. A rectangle is a parallelogram in which the diagonals are equal. So therefore remember, we call rectangle as a special parallelogram because in a parallelogram if one angle is 90 degrees it becomes a rectangle, and in the parallelogram if the diagonals are equal it becomes a rectangle. Now properties of a rectangle, again let us study the properties of rectangle in terms of sides, angles and diagonals. In a rectangle the opposite sides are parallel, opposite sides are equal. See, AB is equal to DC, AD is equal to BC, AB is parallel to DC and AD is parallel to BC. That is in terms of sides. In terms of angles, all the angles of a rectangle are equal to 90 degrees and adjacent angles are supplementary. In terms of diagonals, rectangle has two diagonals, the diagonals are equal. Again I'll repeat, the diagonals are equal, the diagonals bisect each other, that is O is the midpoint of both the diagonals, and also the diagonal form pairs of congruent triangles. Now rhombus. A rhombus is a parallelogram in which a pair of adjacent sides is equal. So that means a rhombus is a parallelogram in which a pair of adjacent sides is equal. Now properties of rhombus in terms of sides, the opposite sides are parallel. The opposite sides are parallel in a rhombus like a parallelogram, and the difference is all the sides are equal in a rhombus. Remember that. The opposite sides are parallel and all the sides are equal in a rhombus. In terms of angles, opposite angles are equal. Here angle A is equal to angle C, angle B is equal to angle D, and the adjacent angles are supplementary. Angle A plus angle B is 180, angle B plus angle C is 180, angle C plus angle D is 180, angle D plus angle A is also 180. Remember that. In terms of diagonals, it has two diagonals, AC and BD. Diagonals are unequal, that means AC is not equal to BD. Diagonals are perpendicular to each other, that means AC is perpendicular to BD. Diagonals bisect each other, that means O is the midpoint of both the diagonals AC and BD, and diagonals form pairs of congruent triangles. Please remember this. The diagonals divide this rhombus into pairs of congruent triangles, and both the diagonals form four congruent triangles here. So the triangle AOD, triangle COD, triangle AOB and triangle COB are congruent triangles. Remember that. Now square. A square is also a parallelogram in which a pair of adjacent sides is equal and one angle is 90 degrees. Therefore, a square is a special parallelogram in which one angle is 90 degrees and a pair of adjacent sides are equal. Remember that. Now, the properties of a square in terms of sides, opposite sides are parallel, all sides are equal. In terms of angles, all angles are equal to 90 degrees, adjacent angles are supplementary. In terms of diagonals, it has two diagonals. The diagonals are equal, diagonals are perpendicular to each other, diagonals bisect each other, diagonals divide squares into pairs of congruent triangles, and these are the properties of a square. Remember that. Now coming to the kite. A quadrilateral in which opposite sides are parallel and pairs of adjacent sides is equal is called a kite. Therefore, in this quadrilateral, we have AB parallel to DC, ABC parallel to AD, and AD equal to CD, and AB equal to BC. So this is not a parallelogram but a kite. Opposite sides are parallel but adjacent sides are equal. So please remember that. A kite is formed by joining bases of two isosceles triangles. What does that mean? Now we have two isosceles triangles here. ADC is one isosceles triangle, ABC is another isosceles triangle. If we join these two isosceles triangles at their base, then we get a kite. Remember that. Now the properties of kite. In terms of sides, opposite sides are parallel. We have got AD parallel to BC, AB parallel to DC, and the pair of adjacent sides are equal. We have got AD equal to DC and AB is equal to BC. Remember that. Then in terms of angles, a pair of opposite angles is equal. We have got a pair of opposite angles equal, and adjacent angles are supplementary. So please remember this, only one pair of opposite angles, that is angle DAB and DCB, are equal in kite, and also the adjacent angles are supplementary, that is angle B is angle A plus angle B is 180, angle B plus angle C is 180, angle C plus angle D is 180, and angle D plus angle A is 180. Remember that. In terms of diagonals, it has two diagonals. Diagonals are unequal. We have got diagonal AC and diagonal BD, which are unequal. Diagonals are perpendicular to each other, and only one diagonal is bisected. If you observe here, only the diagonal AC is bisected by the diagonal DB. Remember that. Now coming to the next important discussion, that is trapezium. Now a quadrilateral in which a pair of opposite sides is parallel is called as a trapezium, and the non-parallel sides may be equal or unequal. Therefore a trapezium is a quadrilateral, all right, only one pair of opposite sides are parallel, and the non-parallel sides are either equal or unequal. Now we have got two types of trapezium, that is isosceles trapezium and non-isosceles trapezium. In isosceles trapezium is that in which one pair of opposite sides are parallel and the non-parallel sides are equal, that is AD is equal to BC. In non-isosceles trapezium, one pair of opposite sides are parallel and the non-parallel sides are unequal here, that means AD is not equal to BC. Remember that. Now the properties of non-isosceles trapezium in terms of sides. A pair of opposite sides is parallel, that means AB is parallel to DC. Non-parallel sides are unequal, that AD is not equal to BC. In terms of angles, the angles at the ends of the non-parallel sides is supplementary. The angles at the end of non-parallel sides, the non-parallel sides at AD and BC, therefore the angles at the end of BC is angle B and angle C. When we add angle B and angle C, it is 180. Add angle A and angle D, it is 180. Remember that. Now coming to the next point of our discussion, the base angles are unequal. If you take an isosceles, non-isosceles trapezium, the base angles and angle A and angle B are unequal, angle C and angle D are unequal. And the diagonals in a non-isosceles trapezium, a trapezium has two diagonals and the diagonals are unequal. A very important property which you have to remember here. The diagonals are unequal, it has two diagonals and the diagonals are unequal. Now coming to the properties of isosceles trapezium, a trapezium in which a pair of opposite sides are parallel and the non-parallel sides are equal is an isosceles trapezium. So we have AB parallel to DC and AD equal to BC in a isosceles trapezium. So in terms of sides, a pair of opposite sides is parallel, that means AB is parallel to DC, and the non-parallel sides are equal, that means AD is equal to BC. In terms of angles, the base angles are equal, that means angle A is equal to angle B and angle C is equal to angle D, and the angles at the ends of non-parallel sides is supplementary. Therefore if you take the non-parallel sides here, that is BC and AD, we can add B and C, it will become supplementary. They are supplementary angles, and also angle A plus angle D is 180 or supplementary. Now the diagonals, there are two diagonals, that is AB, that is AC and BD, and the diagonals here are equal. Please remember, in an isosceles trapezium the diagonals are equal and the diagonals intersect to form similar triangles. Again remember, the diagonals intersect here and the intersecting point is O. It forms two triangles here, triangle AOB and triangle COD, which are similar triangles. So these are the properties of what you call quadrilaterals, different types of quadrilaterals on the basis of the number of pairs of parallel sides. And please remember these properties, very useful properties for calculations, for understanding the basics of geometry, and also we can apply them in proving so many theorems in geometry. So learn them, repeat your reading, and also listen to what I have spoken to you. Scribble them in a book, put it in a book, note down in a book, so that it will help you to refer whenever you need. Thank you.